Hello everyone, in this video we are going to talk about representing vectors. So we can use a vector to describe the change in position or displacement. And it's relative to the x and y axis. For example, we can see there is a vector A and the vertical displacement is 4 and the horizontal is 3. So we can write that vector A equals to 3, 4, where 3 is a change in the x direction, and 4 is a change in the y direction. For this type of vector A, we call that a column vector form. If we times a column vector by a scalar, let's say lambda times pq, that equals to lambda p, lambda q. So in here, you times each component. By the scalar. If you add two column vectors, let us see PQ plus RS. That equals to P plus R, Q plus S. In here, we add X components and Y components. When we talk about representing vectors, we also think about unit vectors. That is a vector of length 1. Well, let us consider x coordinates and let's consider about x-axis and y-axis. So the unit vectors along the x-axis and y-axis are usually denoted by I and G, respectively. Which means I equals to 1, 0, J equals to 0, 1. So then in the graph, which means here is the origin and here is a point 1, 0, and for this vector, this is called I, and we have the point 0, 1. From the origin to this point, we call this a vector G. if we use I and G to present other vectors, we usually written as Pi plus Qg. Let us see if we have a triangle ABC, and AB is a vector 5i, BC is a vector 2g, then the vector AC equals to vector AB plus the vector BC, that equals to 5i plus 2g. This, for any two-dimensional vector, we can written as PQ. This is in the column vector form, and that equals to Pi plus Qg. Now let's move on to do some example question. So in triangle ABC, AB equals to 4i plus 3g, and AC equals to 5i plus 2g. Now ask you to find BC. No, the vector BC, sorry. We can do is to start to draw a diagram. Draw a triangle ABC. So we have AB, that is 4i plus 3g. So we have 4i over here and 3g over here. Now you also know that the vector AC equals to 5i plus 2g. So we can draw that. Here is 5i and 2g. So here is a vector AC. Now it asks you to find the vector BC. We can see that the vector BC equals to vector BA plus the vector AC. That equals to negative vector AB plus vector AC equals to negative 4i plus 3g plus 5i plus 2g. That equals to minus 4i minus 3g plus 5i plus 2g. That equals to I minus g. So we get the answer of that. Now let's move on to see other questions. Given that A equals to I plus 3g, B equals to negative 2i plus 5g, C equals to negative 5i minus g. Find A plus B plus C, and using column vector notation you're working. Now let's write down A plus B plus C, that equals to 1, 3. We only see the scalar in front of I and G. And for B, we have negative 2 and 5. So that is negative 2, 5 plus, for the vector C, we have negative 5 and -1. So that is plus -5 minus 1. So for the x components, that is 1 plus -2 plus -5. That equals to -6. For the y component, we have 3 plus 5 minus 1. That equals to 7. So we got the answer a plus b plus c in the column vector form. Now let's move on to see part B question. Given that a plus 3i plus g and b equals to minus I plus 2g, find 2a minus b in terms of I and g using column vector notation in your working. So we have 2a minus b. And we write down 2 at first, and then to find the scalar of the a. For the x components, that is 3. For the y components, that is 1. So we write down 3, 1 minus b. So we find the x component of b is -1. The y component of b is 2. We have -1, 2. Now what we do, we need to times 2 to the column vector. So that is 2 times 3, 2 times 1, minus -1, 2. We have 6, 2, minus -1, 2. That equals to 6 minus -1, that is 7. And for the y component, that is 0. So here is the answer. Now let's move on to see another question. For part C, we have the column vector A, that is x2, b equals to 5y, and c equals to 1, 4. Given that b minus 2a equals to c, and asks you to find the values of x and y. So follow this equation, we can get 5y minus 2 times x2 equals to 1, 4. So for the x components, we can get 5 minus 2x equals to 1. And for the y component, we have y minus 4 equals to 4. You can also write it as 5 minus 2x, y minus 4 equals to 1, 4. And then you written as in this form to solve the questions. From 5 minus 2x equals to 1, we have minus 2x equals to minus 4. So x equals to x equals to 2. For the y component, we have y minus 4 equals to 4, so y equals to 8. So we have the solution that x equals to 2 and y equals to 8. So here is the end of the questions. You need to remember that how to write vectors in the column vector form. And you need to know how to times the column vector by a scalar. and also how to add two column vectors. You learn that there is unit vector and we use I and j to represent the unit vectors. So I equals to 1, 0, j equals to 0, 1. We can also use the I and j to return any two-dimension vector. Okay, here is the end of the lesson. Hope you enjoy watching it. Thank you.